By the way, I might be called out to a mission during this video.
No, I might as well, so...
Okay,
yeah.
just so you're
Okay,
aware.
anyway, Surds.
Yes, it's the next chapter.
Very exciting stuff, all A&A star things.
Very hard.
Hardcore things indeed. So, what's a surd? Well, it's a snazzy root, isn't it, Wayne?
It is indeed. You know from previous chapters in your indices that you get a root if it's to the power of a half.
Yep.
That might be useful in your surds, it might tie in.
So you might have something like root 4, you know, that's 2. But what if we have something like root 3?
Well, we could just leave that as that, we don't know what it is.
It hasn't got an exact form, and that's what a surd is.
Yes. A surd is when it can't be simplified anymore, it's left in the square root form. So...
Oh, wait, I gotta go for them. Cheese.
Oh, yeah, go on. Sorry, he's got a mission, he's got to go. So, we have these square roots. Now, you can do some jazzy things with these. You need to know some rules. If you have root A times root A, it equals A. But what does the A mean? It means it's the same number. So, root 3 times root 3 is 3. Root 7 times root 7 is 7. How was it? Was it
That's scary. Phase 1 is emission.
Okay, good.
Okay.
I'll just talk you through this rule.
Oh yeah, I like it.
And this is a rule you need to know, only if they're the same. That's what this A is representing, that it's the same constant. If it's root 3 times root 7, it's not just root 37 or something, it's not root 37 or anything like that.
No. However,
there is a rule for this.
There is a rule for that.
It equals root 3 times 7,
Yeah.
like that.
So if that was written in algebraic form, it could be root A times root B, the same as root A, B.
So that would be root 21, which again doesn't have a root, so it's just left as a surd.
It doesn't, and
There's a dividing rule.
there is a dividing rule. So if we have, well, that would be an
Root
example.
A over B, what does that equal?
Well, it's the same as root A over root B.
Yep. So if we have an actual example with actual numbers to express it, root...
Yep. And it's a rule
3
Wayne's
over
already actually used.
Yes, I have used this before. And it comes up in Surds.
It
This is
does.
where it really comes up. So you can see how all of your chapters are linking together already. And these are your rules. Now there's something called Rationalizing the Denominator, which uses that one nearly always at your GCSE.
It does.
And sorry, I'm just
yeah.
sorry. Excuse me. I've got to go on the crackers.
Oh, right, okay. So, rationalising the denominator. As Wayne said, I'm going to do a little more space so I get over these things. It's pretty much just using the thing up here. Now, you should know what the denominator is. It's the bottom part of a fraction. So, rationalising means making a number that we can do stuff with. Remember, it's rational, e.g. not a surd. So when you have something like a over root b, you want to get rid of the root b. So you have an example, like 4 over root 3. So you can't simplify root 3, that's how it is, but you want to get rid of it. So, different colour, I think red will go well, is what we do. So we times both the top and the bottom by this. So we have root 3 times root 3 over root 3. So root 3 times root 3, as Wayne said earlier, that's just 3. And then 4 times root 3 becomes 4 lots of root 3, and then it's a normal denominator, and it is rationalised. And I think that's about as complicated as it gets for surds. Is that about right, Wayne?
All looks in order, yep.
Yeah?
The mission was a huge success. We've got a...
Oh, celebratory tea.
Yeah.
Fantastic.
It's shaken, not stirred, is that right?
I know, that's right. That's how I like my tea. It's quite difficult to do with boiling water.
It can be, but we have the people.
We do have the people and the tools.
Rationalising the denominator, very good, very good.
Yeah?
Unfortunately, sometimes it can get slightly worse.
Oh.
Because there can be expanding brackets. So we'll go through expanding brackets first, then rationalising the denominator with expanding brackets.
Oh, okay. So,
If we rub
expanding
off
brackets.
these rules,
Yep, we should remember them by now and we'll reference them.
3 plus root 3 in brackets,
Mm-hmm.
times 6 plus root 3. Expand those brackets.
Okay, so we expand them like we expand normal brackets, but because of the surds it gets a bit saucy.
First step's nice and easy, it's the beginning.
Yeah,
or
you might use
first
this
plus
as
the first.
foil, so first, outer, inner, last.
So 3 times 6 is just 18.
12, 18, sorry.
Then that one times the end one,
Yeah, which is 3 lots of root 3.
and that is just expressed as 3 in
Yeah.
front of the root 3.
As it
like
was
that,
over here.
Because that's not a root, that times that isn't 3, it has to be root
Yeah.
3 times root 3. Then we do the inners, like this,
Yeah, so it becomes 6 lots of root 3.
expressed like that.
And then we are using a rule plus 3, because it's times root 3 times root 3.
Now because this is x amount of root 3 plus x amounts of root 3, you can add the coefficient together,
Absolutely.
and you can add this 3 and 18 together, because they belong to the same family, they're just numbers, and these are root 3's.
Cool. So we have 21 plus 9 lots of this root 3. And you can simplify that.
You can, it's all divisible
Yeah.
by 3. 21 divided by 3 is 7,
Yeah.
and 9 divided by 3 is 3. The root 3 doesn't do anything when you
No.
divide by 3.
And that just leaves it, and that's, I think,
As simple as that will get, and
Yeah.
that's expanding the brackets. It's worth mentioning you can only add these if the root is the same.
oh yes,
You
yeah.
can't add 3 root 3 plus 6 root 2, that doesn't
No.
work. And there's no rules or anything, you can't add what's in there or anything.
No, you have to leave it as it is, which is okay, because root 3 and surds are normal things to work with.
And then you can combine that with this by having something like 3 plus root 3 over root 3. To
Yeah.
rationalise the denominator, you do the same thing as Triv so ably described. Root 3 over root 3, you get the bottom becomes 3.
Yeah.
Then you'd have this to expand on the top.
Yeah, so you'd have 3 lots of root 3 plus 3.
That times that is 3, and that times that is 3 root 3.
And then you can finish it off.
That would cancel with that and get root 3. It would also cancel with that to get 1.
Absolutely, and that's surds.
This is A, it's all A star except right at the start,
Yeah,
and that's still A.
it's
So
an
it's
A
very
grade, it's
tricky
hard
stuff.
stuff. If you can get it, marks where you can. They're good things.
Make sure you ask us questions if you need to. We haven't said it in a while.
We haven't said it in a while, but you can message us on, you can comment, question below, we'll do a video about it, or message you. Or you can go on Facebook, or you just find us by Clover Dragger Square, typing that into the search bar.
If you're lucky enough to know us in person, feel free to approach us and ask us questions.
Yeah, you can do that.
The cat's come to
The
celebrate.
cat, it loves cheese and crackers. I don't
What
know.
kind of gadgets are on the cat?
I don't know, but I want to have my tea with it.